Hello, this is Rob again. I'm finishing up section 5.3 in business calculus. I'm on example 6. Um, and we can first see that we're doing use substitutions, and we're going to be looking for the use of the log rule. So I'm thinking I'm going to look for the integral of 1 over u. So I'll probably let this denominator be u. If we do so, I'll look for clues for things that could be used for du. That are left over. And I see something. The derivative of x squared is 2x dx. And the reason why you write dx is because you took the derivative of du. So I'm going to replace part of this 6x dx with 2x dx. But I notice that we're missing a little piece because it's not identical. This is 6x and this is only a 2x. So it looks like I need to multiply both sides by 3 in order to make everything equivalent. So I get an equivalent statement. 3 du should equal now the 6x dx. So there's my replacement. In terms of u, I'll say the integral of 1 over, I've replaced all of this with u, and I'm replacing all of this yellow with 3 du. And remember, if it's a constant, we can pull it out front. So all I really need to do is find the integral of 1 over u du using my log properties. I know that this is 3 ln of the absolute value of u, which my u substitution says u really is, if I put it back into x squared notation, x squared plus 1. And don't forget about the constant. And the author agrees. The last example that is from this section 5.3 is actually threefold. Again, this looks like a multi-step problem, but at least the numerator degree is equal to the denominator. Where in part C, we'll talk about this, the numerator is less than or greater than the denominator. It makes things a little bit more complicated. And here I see a compound fraction because e to the negative first is really 1 over e. And I'll show you how to clear compound fractions. But let's start with this one. I think I can break this up into 3 separate problems and then integrate each problem separately. So I'll rewrite this as 3x squared divided by x squared plus 2x divided by x squared minus 1 divided by x squared. We typically don't go this direction. Usually in algebra, I'm giving this blue and I find common denominators and come up here with this as the simplified. But in calculus, sometimes we want to use this property so that we can break up each integral and integrate individually. So this just becomes the integral of 3 plus the integral of 2 over x minus the integral of, we could even say x to the negative second if I bring these to the numerator. This might even be better written as 2 to the negative, 2x to the negative first, because when I integrate, I'm going to increase by 1. Well, that doesn't work real well for this one because I can't increase that by 1. I'll get a 0. So maybe I should use my log rule and leave this divided by x. So it might work in some cases, but not in all. Let's see what we can do here. This is really an x to the 0 now. I'll increase this by 1. That's the integral rule. So it becomes x to the first. I'll divide by the 1 and multiply by the 3. This one I'm going to have to use my log rule. 2 is a constant. It comes out front. The integral of 1 over x is the ln of x. And for this last one, if I increase this exponent by 1, it becomes x to the negative first. Divided by negative 1, I'll just say minus plus c. You might want to rewrite this as 1 over x. We'll see if the author does. Yep. Again, usually simplified version is no negative exponents. Although sometimes we write things in terms of negative exponents just because it's easier to integrate. You might want to put them back. It doesn't look like the author ever did put it to be x to the negative first. Same principle though. For the second one, again, I talked earlier about this compound fraction. This is really 1 divided by e. In fact, we could even write it that way, so maybe you could see better what I'm about to do. So this is really 1 over e to the x. So to clear this denominator, I'll probably say, let's multiply by a creative unit of 1. We can do anything to this blue fraction we want as long as we multiply by 1. So distributing in the numerator, I get the integral of e to the x, and distributing in the denominator, I'll get e to the x plus 1. And so you're saying, well, that doesn't look a whole lot better, but at least I got rid of the negative exponent. Next, I'll look for a u substitution, and again, since I'm using the log rules for this, I'll probably let the denominator be u. And if you do that, I'll look to see if again, this may not work, so I might have to try something else, but I'll try this first. And it does look like this is going to work pretty good because the derivative of e to the x is e to the x, which is nice, e to the x dx, because that's what I have in the numerator. So I'm going to replace all of this e to the x dx, e to the x dx with du, and the yellow gets replaced with just u. So I have the integral of 1 over u, and then all of this blue becomes du, which we know now using the log properties that this is the natural log of just u. But I'm going to replace u with e to the x plus 1. That's my u substitution. We'll put that back and say plus c. And we'll check, I believe the author, yep, the author is going to have the same. Again, the author works it a little bit differently, doesn't show all the work, and that's why I wanted to make this video, just so you could see how I'll be working these out. This one, again, then since the numerator is greater than the denominator, causes a little bit of problem. There's one of two ways I could try to simplify this, because I just don't think my u substitution is going to work. You can try, but if I let the denominator be u like I did on the last problem, I don't get anything that resembles du from the derivative of x minus 1. It's just not going to happen here. So every time you see this improper fraction, I would recommend either long division to try to rewrite the fraction, or for those that you remember how to do synthetic division, I might even recommend synthetic division. Synthetic division says don't use the factor x minus 1, instead use the root. And the root here for x minus 1 equals 1. It's when, remember, roots are x-intercepts, so you set this equal to 0 and then x equals 1. So I'm going to synthetically divide by the root of 1 because the factor is x minus 1. I'll use the coefficients here, 1x squared, 1x, and 1. Bring down the first term. You just always bring down the first term for synthetic division. Multiply, add, and multiply this 1 times this 2, and add again. So remember, this was my x squared term, but you divided out one of those factors. So this is now just 1x squared plus 2x, and I have a remainder now of 3 divided by the factor x minus 1. So I will write this now as the integral of x. I made a mistake over here. This is no longer x squared. This is just x. I got to decrease by 1. So let's see. This was an x squared. I factored out an x. That leaves me with just 1x plus, this is just the number 2, and this is the remainder. I'm so sorry. This 2 gets decreased by this 1. Well, you can see it clearly here. If you take x into x squared, it goes 1x times. And so this x is this x. So maybe I should have done long division. Synthetic is nicer. All right, so plus the integral of 2 plus the integral of 3 over x minus 1. So integrating, integrate means we're going to increase this by 1 and divide by it. So I can either say divide by 2 or put a 1/2 out front. This is an x to the 0. We'll increase this by 1 and make that x to the first and divide by a 1, which I don't need to write. This one I might have to do a u substitution. If I let u equal x minus 1, then du equals just 1. Well, I don't need the 3. I'll pull the 3 out front. It becomes 3, the integral of 1 over u, which you see is another log property. This is the ln of u, but instead of writing u, we'll write x minus 1, putting it back in terms of x. So the final answer, 1 half x squared plus 2x plus all of this 3 ln x, and we don't forget about our constant. That's a long answer. Hey, yep, the author has the same thing. Instead of doing 1/2, it looks like they just left it divided by 2. So I believe that's the end of section 5.3. I'll try to create a section 5.4 right after this video. Email me with any questions. Thanks. Bye.